In this video, you will be learning how to write chemical compounds.
Make sure to have your periodic table with you.
First, we will be learning how to write a simple ionic formulae. This is when we are combining a metal and a non-metal. The metal always comes first in the formula, and metals have a positive ionic charge, and a non-metal has a negative ionic charge. First, we will be using magnesium, which has an ionic charge of +2, which is our metal, and then our non-metal is oxygen, and it has an ionic charge of -2. Both of these charges together make an algebraic sum of 0. So when we write the formula, we only have one magnesium atom and one oxygen atom. So it's MgO. Our next formula is using potassium as the metal, which has an ionic charge of +1, and bromine, which has an ionic charge of -1. The algebraic sum of these two, metals and nonmetals, is equal to 0. So we have one potassium atom and one bromine atom, which is KBr. Our final compound is aluminum, and it has an ionic charge of +3, and fluorine, which has a charge of -1. To make this algebraic sum equal 0, we need to add 2 more fluorines to this compound. So then we'll have a charge of +3 and -3, which will equal to 0. So that means we are going to have 1 aluminum atom and 3 fluorine atoms. So it's AlF3. Now we will be learning how to write a multivalent ionic formulae. This is when we combine a metal and a non-metal, but the metal being used can form more than one possible charge. Roman numerals are used to indicate which charge is being used. Some examples of multivalent metals, which is a metal with more than one ionic charge, are iron, titanium, and nickel. So all of these elements have more than one possible charge. First, we will be combining nickel and oxygen. So first we write the metal, which is nickel, and its symbol is Ni, and it has a charge of +2, as is indicated by the Roman numerals, and oxygen has a charge of -1. So when the algebraic sum of both these equals 0, we are left with 1 nickel atom and 1 oxygen atom. The next element we are doing is gold, and we are combining this with chlorine. Gold, indicated by the Roman numeral signs, has an ionic charge of +3, and chlorine has an ionic charge of -1. So to make that algebraic sum equal 0, we have to add 2 more chlorines. So then we have +3 -3, and that gives us 0. So we are left with 1 gold atom and 3 chlorine atoms, which makes AuCl3.
Now I will teach you how to write a multivalent polyatomic ionic formulae. If you come across a question like, let's say, gold 3-phosphate, to write a formula for this, you'll first have to figure out the charges for each part. So we know the symbol for gold is Au, and the charge would be +3. And phosphate, symbol being PO4, with a charge of -3. Since we know gold is a multivalent ion and it has multiple charges, how do we know which charge to use? Since there is a Roman numeral 3 here, we know to put a 3 over here. Now, using the algebraic sum, we can put this into a formula. We have one gold ion and one phosphate ion. So this would be +3 and -3, which equals 0. So the formula would then become AuPO4. Now let's try another one. So once again, we have to figure out what the symbols are for both these parts. We know the symbol for iron is Fe, and the symbol for hydroxide found on the polyatomic sheet is OH with a negative charge. So since we know iron is a multivalent ion, we don't know what charge we are going to use. But because there's a Roman numeral of 2 here, we know automatically that the charge will be +2. So now using the algebraic sum once more, we can figure out a final formula. So the charge for iron is +2, and the charge for hydroxide is -1. So to balance it out, we need to add another hydroxide in there, and this will become -2, which equals 0. So the final formula for this one would be Fe bracket OH and bracket 2. So we put brackets here because there is not just 2 hydrogens, there is both 2 O and H.
Now we will learn how to name a simple ionic formulae. So you must remember that in ionic compounds, the metal is always written first with the non-metal following after. The first example we are going to be using is MgO. So first we want to write what the metal is, which is magnesium. And then we write what the non-metal is, which is oxygen. But when naming ionic compounds, the negative ion in the binary compounds ends in "ide." So oxygen will turn into oxide. So it is magnesium oxide. Our next example is KBr. So first we're going to write the metal, which is potassium, and then we're going to write the non-metal, which is bromine. But in binary compounds, the negative ion ends with "ide." So we're going to take off the ending of bromine and change it into "ide." So the final product is potassium bromide. So our last example is CaCl. So first we're going to write the metal, which is calcium, and then the non-metal, which is chlorine. But we need to change the ending of the non-metal, which is chlorine, so it ends with "ide." So it is going to be calcium chloride.
Now we can learn how to name a simple polyatomic ionic formulae. Let's try one. Say you were giving the formula CaCO3. To write that out is very easy. Simply put the metal, in this case calcium, followed by the non-metal, which is carbonate. And there you have it, your written formula. Let's try one more. So the formula Li2SO4 is given to you. Start off by writing the metal, that being lithium. After, write down the nonmetal, so sulfate. Altogether, you have lithium sulfate.
Now we're going to learn how to name a multivalent polyatomic ionic formulae. Multivalent metals are metals that can have more than one ionic charge. And in order to write the name for compounds containing metals that form more than one ion, we must predict the charge on the ion from the formula. So in this formula, gold has an unknown charge because it is multivalent, but phosphate, PO4, has a charge of -3. So for the algebraic sum to equal 0, gold will have to have an ionic charge of +3. And that will leave us with one aluminum atom and one phosphate atom, which gives us the original formula. So to write this, we write the metal first, Au, which is gold. We write 3 in Roman numerals because that is the ionic charge we used. And then we write the polyatomic ion, which is phosphate. So our next example is CO2SO3. And the metal in this compound is cobalt, and it is a multivalent metal, which means it can have more than one ion charge. And the polyatomic ion is sulfite, and it has a ionic charge of -2. So in order for the algebraic sum to equal 0, we are going to need 2 cobalt atoms and then 1 sulfite atom, so it equals CO2SO3. So when we write this formula, we first write the metal, which is cobalt, and the ionic charge we used is 1. So then in Roman numerals, we write 1, and then we write the polyatomic ion, which is sulfite.
Here's how to write a multivalent ionic formula. First of all, we need to know what a multivalent ionic formula is. A multivalent ionic formula consists of a metal and a nonmetal. The metal comes before the nonmetal. The metal has more than one ionic charge. That's what makes it a multivalent ion formula. What makes multivalent special are they use Roman numerals for the charge. 1, 2, 3, 4, 5, 6, 7, and 8 will be as high as we are going for ionic charges for now. An example of a multivalent ionic formula is AuCl3. First of all, we need to name the multivalent ionic formula. We also need to make sure that we place our charges with the name. The first name of Au is gold with a charge of +3 +1. The second one is chlorine with a charge of -1. These are both found on the periodic table. Metals on the left, nonmetals on the right. Now we use the algebraic sum method to determine the charge of the metal. So because we have 3 chloride as a subscript, we need 1 gold. Now to determine that there are 3 gold needed for an ionic charge, we use the algebraic sum method, and they have to cancel out t equals 0. And on the whiteboard I did put aluminum, but it's supposed to be 3 gold are needed. Now step 3 is to determine what the name is actually going to be. The name uses Roman numerals, so in this case it'll be gold, Roman numeral 3, chloride, because IDE is added to the end of non-metals. Now example 2 is copper fluoride, CuF2. Again, we name the multivalent with its charges. Copper plus 2 plus 1, fluoride minus 1. We use the algebraic sum method to determine the Roman numeral needed. So here I have 2 fluorine, 1 copper. So to cancel that out, that means I need 2 copper. Our Roman numeral will be 2. Our final step is to determine the Roman numeral and its name. In this case, it'll be copper 2, because we needed 2 ionic charges, fluorine. But because we need to add an IDE, it'll be copper 2 fluoride. Some key points are use IDE at the end of a nonmetal. Chloride has IDE. Use Roman numerals to show charges. Roman numerals only go with the metal. And reduce when necessary. So our next one is how to write a polyatomic ionic formula. First of all, we need to know what a polyatomic ionic formula is. It is where a metal on the front side of the periodic table, but only on the left, is combined with polyatomic ions on the back side of our periodic table sheet. So example 1 is aluminum ions and hydroxide ions. First step again is to write the name of the elements. This time we're not writing the actual name because we already have it. We are just writing it as an element. Make sure you add the charges placed with each one. So aluminum has a charge of +3. And hydroxide has a charge of -1. These will become very important when you're wanting to write out the formula. Step 2 is to cross over the charges -1 will be crossed over to aluminum, and +3 will be crossed over to hydroxide. This will create Al -1OH3. Step 3 is to get rid of unnecessary +1s and -1s, and also to put brackets around subscripts on polyatomic ions. This finally gives us our proper written formula, Al bracket OH bracket 3. Example number 2 is sodium ions and oxalate ions. Again, we name the elements with their charges, so sodium is Na+1, and polyatomic ion, oxalate ion, is found on the back side with C2O4 -2. Cross these over again to get the charges down into subscripts, which equals Na2 bracket C2O4 bracket positive 1. Again, no brackets are needed if it's a positive or minus 1 on the polyatomic. Final step is to add brackets and take out minus 1s or positive 1s. So our final written polyatomic ionic formula is Na2C2O4. For key points, our brackets always go around polyatomics except for minus 1, positive 1, and to always keep subscripts even if they are attached to the polyatomic.